Hello guys, and welcome to Introduction to Electronics. Hello guys, and welcome to Introduction to Electronics. So, first of all, I'd like to greet you. I hope you're having an amazing time, an amazing day, okay? So, since you're already here, I would just like to welcome you here, okay, in our course and Introduction to Electronics. So electronics is fun, and without further ado, let's start our journey. So before we start, we need to give you some insights about the safety instructions, okay? So the safety instructions for us is basically we will never work on a circuit while power is applied, okay? So make sure you turn off the power when you work on your circuit. Then also keep your work area clean and dry, okay? And make sure always wear some safety goggles, okay? And be especially careful when you solder, because you know a hot solder iron can easily burn you. So you need to be extra careful. You need to, if you don't know how to operate it, you should seek guidance before. You could go to some of the makers lab around you, or you could just speak to someone in your school who's expert in electronics soldering, okay? And also make sure you have safety equipment ready, like such as fire extinguisher or a first aid kit, okay? And a phone nearby is always a handy tool, right? Now it all starts with a charge, okay? So what is charge? So charge is basically, it is the fundamental property of any particle in this universe, okay? So we all know little or something about atom, right? Like, I mean, you probably studied about atom, right? So this is the nucleus of the atom, and there's something on this thing, like this is called the orbit, where there's an electron revolving all the time, okay? And on the nucleus you have your positive charge and you have your neutral particle, okay, which is known as neutron, and this is our proton and this is our electron, okay? So electrons are negative charged particles, so what they do is they revolve around your nucleus in an atom, and atoms are the smallest particle in the universe, okay, which retains the properties of an element, okay? So that's what we're explaining here. So they are the smallest particles that retains the properties of an element. Here we are going back to physics and chemistry basics, okay? So as you can understand, we've already discussed about it, right? Great. Now, there are two types of charges, as we have seen in the previous slide, which was basically proton and which is positive, and the negative charge is electron, okay? So the thing is, as we've seen in the previous slide, that protons were the positive ones, and what they do is they have a kind of electric field around them, okay? So since they're charges, right, so they exert some kind of force through their electric fields around them, okay? And that's what literally generates your electricity, which is the flow of the negative charge, okay, which is electron, okay? Great. Now, this is what we're talking about here. Now, the movement of this negative charge is what produces the electric current, okay? So we measure the charge in the units of coulomb, okay? Now, one thing you need to remember is basically whenever your negative charge, let's say this red one or the blue one here, this is the cross-section of a wire, and we represent current as I, okay? So this electron negative charge is flowing from one point to the other point, okay, just like this, so we will call this current, okay, since this is a cross-section of a wire, so you can understand. And now we measure the charges in coulomb, so the unit of charge flowing would be coulomb, according to the scientist coulomb. Now, what is current? So current is basically moving electrons in a loop, okay? So why is it a loop? So loop is because it has to be a closed circuit. So if imagine there's open end, okay, in the circuit, so the electrons will not flow because it will not have the pressure, right? If you need to flow the electrons in the open area, so it has to have tremendous amount of voltage, okay? So we're going to come to that next. Now, so imagine this is our circuit, and this is a wire. This is the same wire, but we took the cross section here, and in this part we have something, a different sign. Okay, so this sign is looking like this. One is longer and one side is smaller. Okay, so we call this potential difference. Okay, or you could say voltage. So what is the voltage? Voltage is basically the driving force of the current. Okay, so this is what makes the electric charges or the electrons move from point A to point B. Okay, so this is how the potential difference makes your electron or electricity move from point A to point B. Okay, like this. So you can understand what is your voltage, right? So what is the most essential component in our circuit? So this is a closed loop circuit. Okay, so the most essential thing in our circuit is voltage, because without voltage you cannot have electricity. Okay, because there would be no driving force, there would be nothing to give the pressure without the potential difference, right? So you would not have electrons flow and you will not have electricity. Okay, so here we're talking about it again. So voltage or potential difference is the pressure that pushes the negatively charged electrons, they're negatively charged, which is basically our current, through a conducting loop to accomplish some work. Okay, and the symbol for voltage is V, and it is measured in volts. Now, what is schematics? So schematics is basically simplistic form of drawing, okay, where we can represent our electrical component just by drawing the simple signs, right? The simple representation. So for example, for volts, you get like some sign like this, right? This longer one and the smaller one, you call this volts, and this one is basically a resistance. Okay, and there are other signs, other representations. We're going to come to them like in a later slide. So now another important thing we need to learn about is resistance. Okay, so resistance is basically a property of electrical component. You can call it like whatever resists. Okay, so basically everything, the fundamental is basically based on electrons flowing. Okay, so now what we do is we control the flow of electron. Okay, so that's how you have your electrical components. Okay, electronics. So resistance is what basically it slows down the flow of your electrons, negatively charged particles. And yeah, resistors are the components that has this property of resistance, which resist the flow of negative charges. Okay, so imagine we have two types of signs for resistance. One is this like zigzag, and the other one is like a square bracket. I forgot to give that one just a square. Okay, nothing inside. So what we represent with this is basically electrons has to go further apart. So it has like this is a metaphorical representation that electrons will need longer or more energy to flow through this. Okay, so you will need more voltage, so there will be a voltage drop across these components. Okay, so it is a little more difficult for the current to flow through here. Okay, imagine there's a simple conducting wire, so that's going to flow easily, and at this point it has to cross like more zigzag, and there's probably going to be some other components inside which is going to slow down the flow of electrons. Okay, so that's going to resist the flow, so that's why we call it a resistor. It resists. Okay, it's simple, right? So resistance is represented by R, and the unit is omega. It's taken from a Greek symbol, I think. Yeah, omega symbol, and we pronounce it as ohms. Okay, so the unit of resistance is ohms. And here's some pictorial representation of resistors. So this is like a brown one. This is this is a dark brown one. Yeah, and this is how we represent in schematic forms. Okay. And another thing you need to remember is, when we use the square brackets, we represent units of something. Okay, so for example, every time you see the square brackets, you'll understand this is the unit of the quantity. Okay, whatever you're talking about. So for resistance, it'll be ohms, right? Simple. Great. And now let's learn about conductors, insulators, and semiconductors. So what is a conductor? So a conductor is basically wire, or you can say component where the electrons can flow easily, okay, so they can go from here to here to here, right, simply, so they're conduct basically, okay, that's how the name comes from, okay, conductors, okay, they conduct, okay, whatever conducts, we call it conductors, okay, and since everything is based on electrons flowing, basically electricity, electric current, so we will call it conductors, okay. Now you can understand what would be insulator, right? So insulator, basically it would not conduct because they don't have the property to, you know, let the electrons flow, so that's why we will call them insulators, okay. So we need insulators to protect ourselves from, you know, electric currents, okay. So for example, you've probably seen, you know, woods or rubbers, okay, so they don't have the property to flow any free electrons, okay, so that's why they don't conduct electricity, so we call them insulators, okay. And now we will learn about semiconductors, so you can understand they can conduct semi, okay, they can conduct partially, okay. So what we do is in nature, you know, we find some of these elements like silicon, whose atomic number is 14. So now we need to go back to chemistry, you know, a basic chemistry from GCSEs. So it'll be basically like, you know, going through the periodic table basically. So what is the atomic number of silicon? It's 14, right? So atomic number is 14, so that means in the first shell we get 2, then we have 8, then we have 4. Now the thing is, when silicon has 4, you know, like electrons in its last shell, we will call it like valence shell, okay, so they form covalent bonds, right? So what we do is we add a little bit of impurity, okay. So you know, in covalent bonds they share electrons. Now if you add impurity to it, we call this process doping, okay. So now when you add impurity, what happens is that extra electron will flow, okay. So every time you pass some current through that, the electron will move, okay, because you're putting an extra electron there, and we need electrons to flow from one point to the other point for it to generate some kind of electricity or current, right? So you understand. So wherever electrons can flow partially by a process of doping, it's basically in semiconductors, okay. So we use the silicon, or we use gallium arsenides, okay. Some other forms we're going to learn more in depth and later, okay. So there are two types of our semiconductors, okay. So one is p-doped, another is n-doped, okay. That's why we say, you know, p-type semiconductors, n-types, okay. So for the p-types we create a positive hole, okay. So we like decrease one of the electrons from the structure, and in the n-type we add an extra electrons, okay. So that's why this is what conducts, and for this one we create a positive hole, so the other next electron would move to that one, okay. And for this one you have an extra, so that's why the extra one would move around, okay, like metals. So now let's learn about types of current. So there are two types of current, okay. So the first one is called alternating current, the second one is direct current. Actually I should have talked about this one earlier, okay. Direct current, then alternating current. So now, as you can understand, direct current is basically direct, okay. So you can look at the graph here if you understand graph. So direct current is basically there's no change in the direction of your current, okay. It doesn't go up or down or anything like that. It just goes in only one direction, okay. For the alternating, it goes up and down, it goes up and down, so it alternates, okay. So that's what we call it, alternating current. So typically in our households, okay, we have like 110 volts or 220 volts, like depending on which location you live in the world, okay. Usually it's 50 hertz to 60 hertz, okay. So basically how many times it's going to alter. So 50 hertz is basically it's going to, you know, change its like turns 50 times, okay, or 60 times depending on where you live again. And if you look at a circuit, we're going to discuss more in depth later, okay. So now there's a story you would like to know, which is basically war of the currents, okay. So there's this two person you need to know about. So the first person is Nikola Tesla, and the second person is Thomas Alva Edison, okay. So Thomas Alva Edison, like, I mean, you probably heard about this guy, right? So he has this famous quote, like, you know, he found 10,000 ways not, you know, that wouldn't work to light up the light bulb, right? So that's the thing. So this guy never gave up. He's like really persistent. Like both of them are my idols basically. Now the thing is, Tesla, so this guy is for alternating currents, okay, and Edison, he is for direct currents. Now the thing is, Edison used to, you know, run a lab and where he used to promote this DC current. Okay, so he was in favor of DC and Tesla was in favor of AC. Now the thing is, so DC current was short ranged current. Okay, so before we had like not high voltage. So what happened is DC current couldn't pass electricity from more than a 2-kilometer range. Okay, it was really difficult with with so much losses and stuff. So what happened is Nikola Tesla discovered the alternating current. Okay, with his motor structure. So what happened is with this alternating behavior, what you could do is you could pass current to the whole of the country. So he literally light up the whole world with his electricity, right? Just think about it, like you need current, electricity in your day-to-day life. It's a fundamental necessity now, right? So what Edison did is he got a bit political. Okay, so he started showing the bad effects of AC current. Okay, so he started killing animals with his AC current, because AC current is really powerful. As you can see, you can light up everything. So he used those currents to kill animals like elephants, or some say horses, and sometimes they used to electrocute people with the alternating current because it's powerful, right? So you can understand. So that's why he tried to blame and call bad names, or say bad things about the AC. But then Tesla actually promoted the AC, and he defended it really good ways. So that's why we have our electricity today in our home, right? So we're thankful to this guy. Now, the many people in the world, they don't know about Tesla, they just know about Edison, because this guy is a genius. This guy is a sheer genius. I'm a huge fan of him. Okay, he is way ahead of his age. Okay, but you probably heard about the company name called Tesla, right? Tesla Motors. So yeah, that Tesla comes from this guy's name. Okay, now voltage divider rule. Okay, so this is just a basic introduction here. So voltage divider rule is basically it states how we can divide voltage in circuits, okay, through providing some form of resistance to the electric current. Okay, so it's basically, imagine you have a voltage source here and you have two resistors, right? So what happens is you pass some current through it, right? And what would happen is you'd need a little bit of voltage, right? So voltage drop, there would be a voltage drop here, voltage drop here. Now whenever you have these resistors, so there would be a voltage divided in between them, right? And then you can get some voltage out as well. So that's why we call it voltage divider. Okay, now there's another one, the similar way we divide current as well. So you have your current source coming in here. Now imagine if you have 40 milliamp going in from here. So by the way, ampere is the unit of current, and milliamp is very, very short, small amount of current. So if 30 milliamp is going here, so what would be the other branch getting? 10, right? Just simple. 30 plus 10 would be 40. If this current is going through here, it has to go. If 30 is going here, 10 has to go here, right? So this is kind of simple, right? Now, Kirchhoff's voltage law. So, what is this law? What is it like? What is it? So, this law talks about how we can divide voltages in any circuit. So this is the most basic form. Okay, so in Kirchhoff's voltage law, what we do is we have a closed loop circuit. Okay, we have to have a closed loop circuit. So what is a closed loop circuit? So your circuit has to be closed. Okay, so this is the potential difference, is a voltage. Now this is another voltage drop, voltage drop, voltage drop. Okay, so it could be some components. Like it could be a resistor, it could be a motor, it could be something. Okay, now what he says is, Kirchhoff says is that the total voltage around a closed loop must be always zero. Okay, so for example, your V1, V2, V3, all of them has to be equal to Vs. Okay, so that is what means by voltage has to be zero. Okay, so basically if you take all of them in one side of the equal sign, so Vs minus V1 minus V2 minus V3 equals zero. Okay, so that's what we do. It's just like an algebraic manipulation. Now let's learn about Kirchhoff's voltage assignment. Okay, so here's the assignment. You guys can pause the video and do the assignment and put some answer for this on the comment section below. Now, Kirchhoff's current law. So for closed loop circuits, okay, Kirchhoff's current law is basically for closed loop circuits. As you've seen, there's closed loop. Okay, so now in every point, okay, so we will call these points nodes, okay, so where like basically different branches meet, okay. Now for closed loop circuits, what happens is the algebraic sum of currents in a network of conductors meeting at a point is always zero. So basically meeting at a node is always zero, okay. So in any given time, in any current in any nodes, okay, in any nodes, current going in would be equal to current going out, okay. It could be the other directions, any direction, doesn't matter, okay. So for example here, I1 is going in, I2 is also going in, so both of them are adding up, right? Both of them are adding up. Now something is going out, so that must be equal to both of them, right? It's kind of simple, right? So I3 would be equal to our I1 plus I2. Okay, so this is what Kirchhoff's current law is. It's kind of really simple, actually. Now you have a simple assignment here. So I've given you I1, I2, I3. Now here are some values given. I1 equals to this, I2 equals to this. What would be I3? Okay, for 2 assignments. Make sure you do them and put them in the comment section below. I will give you the answer at the end of the video. Okay. So what is the basics, okay, of electricity? So it is all about just controlling of electric current, right? So it's about putting electric current through any suitable components, regulating it, okay? So it's basically regulating your electron flow through any kind of components, okay? So for example, you use resistors to, you know, control the resistances, you use capacitors to store electric charge, and you know, all these other components to just get some, you know, suitable task out of it, okay? So for example, if you want to light a torch light, so what do? You know, use a potential difference. You use a battery to light it up, right? So there is some electron flow through your LED or whatever form of you know, illumination process you're using, right? That's the thing. So that's the basics. So we use electric current through, you know, any suitable components. We just control it, okay? Now there's not much flexibility with analog electronics, okay? So there's more flexibility with digital electronics, okay? So we're going to go through digital electronics in the future. So now, what is the difference between electrical and electronics engineering, okay? So electrical engineering is basically, or electrical deals with more related with, you know, power transmission, power control, power storage, power generation, okay? So more to do with you know, power, okay? And electronics is basically smaller level of current, so this is a higher level of current, okay? Electronics basically circuit designs, you know, the circuits you've seen, breadboards or PCBs, printed circuit boards, or microcontroller unit designs, or hardware and platform, you know, for electricity. Usually basically smaller components, and these are like larger components, or you can see electricity grids and all these stuff, okay? So electrical engineering would deal with those stuff, and electronics would deal with this, okay? So motors, controls, and all these stuff will come here, like if it's a higher power motors, okay, higher voltage motors, okay? And if it's a small DC motor, like 1, 2, 3 volts, you could use in here, like, I mean, a little bit more as well, okay? There's a range. So you know the difference between electrical and electronics engineering now, right? Great, guys. So here are some resources, okay? So you could Google them up, useful books names, okay? So basic circuit analysis, Shom's outline, or introductory circuit analysis, introduction to circuits, okay? Just Google them. They've got some great, you know, materials. You could look at them up, or you could just you know, find it in YouTube if you have any other questions or anything, okay? So thank you for watching, guys. I hope you're going to have an amazing day, and I hope this video provided value for you. Do make sure you put some comments, or, you know, put a thumbs up below if you liked this video and it helped you. Thank you so much, guys, and make sure to ask or leave any questions if you have them, okay? Thank you so much. Have a great day, guys. Bye bye. Take care.